So in the given problem, he is asking the voltage gain for this transistor configuration. So the voltage gain in this configuration is equal to minus GM into RL parallel with RC. RL is nothing but this one, this is RL and this is RC. So the only unknown here is GM. GM is nothing but the collector current, DC collector current divided by VT. Actually this is not VT value, this is not actually 325, this is actually only 25 millivolts. It was wrong, the data is wrong, just corrected, this is 25 millivolts. Then so in order to find out GM, you have to find out the collector current, DC collector current. So how to find out the DC collector current? To find out the DC collector current, you have to write the DC equivalent of this circuit. So when you are writing the DC equivalent of this circuit, we know that the capacitor will be open for DC. So that means the above circuit will become like this. This is emitter, this is collector. R1, R2, RC, supply voltage VCC, and this is RE. So we know that in general the base current will be 0. Generally it is very small, but in this case it is 0 because we know that base collector is nothing but the collector current by beta. So as clearly mentioned in the problem, beta is very large. So when the beta is very large, then this will become 0. So when IB equal to 0, then the collector current will become the emitter current. So I'll find out the emitter current from this, which is nothing but the collector current. So in order to find out that, I'll write the equivalent circuit, or I'll find out the Thevenin's voltage between these two terminals A and B. So V Thevenin's will become the voltage across this one, that is nothing but VCC into R2 by R1 plus R2. Similarly, R Thevenin's will become R1 in parallel with R2 by 1 plus beta. So again beta is very large, so that means this will become 0. So that means this whole circuit you can write as V Thevenin's with Thevenin's equivalent resistance is 0 and this is RE. And the current which is flowing here is IE. So IE, this is equal to IC, this is equal to V Thevenin's. And one more thing, if you see here, this is a base and this is emitter, na? So there is a voltage VBE is also will be there. So that means this is a B and this is E. There is some voltage will be here. So that means IC is nothing but V Thevenin's minus VBE by RE. So this is equal to V Thevenin's is nothing but VCC into R2 by R1 plus R2. So this is 9 into R2 is 3 by 3 plus 6 minus VB is 0.7 divided by RE is 2.3 kilo ohm. This is equal to, these two gets cancelled, 3 minus 0.7, this is 2.3 by 2.3 kilo ohm. This is equal to 1 milliampere. So IC you got. Now once you know IC, you can find out GM. GM is nothing but IC by VT. This is nothing but GM. This is equal to 1 milliamp by 25 millivolts. This is equal to 1 by 25. Now AV, which is nothing but minus GM, this is nothing minus 1 by 25 into RC parallel RL. That means RC is here 3 kilo ohm and load resistance is also 3 kilo ohm. That means 3 parallel 3 means this will become 3 by 2 kilo ohms. This is nothing but minus 1 by 25 into 3000 by 2. So this will become 1500. 25 force. So AV equal to, you will get minus 60. Sorry, it's not volt, only minus 60 because it's a gain, na? So it is only minus 60. So from the options, option D is the right answer.